students. So in this clip, we're going to be going over an example on how to graph hyperbolas, okay? We're going to be focusing on graphing hyperbolas that are presented in standard form, okay? So let's just indicate that. We're going to be graphing hyperbolas that are in standard form. Okay, let's go ahead and write down the instruction for the example we're going to be doing. So we are to find the center, direction of central box, direction of central box, and their classification, and the C for the foci, and the opening of the hyperbola. Okay? Alright, after doing that, we're going to graph the hyperbola and label completely, stating the coordinates of the center, vertices, the focus, which is the foci, the two foci, focus, and the equation of the asymptotes. Okay, so that's what we're going to do here. Alright, so let's go ahead and take a look at the first example we're going to do. Example number 1, we have the hyperbola in standard form given by the equation x plus 2 square over 4 minus y minus 3 square over 16 equals 1. Okay? Alright, so first thing we're going to do is we're going to find the center. To find the center, we'll just take the opposite of the number next to the x, which is negative 2, and the opposite of the number next to the y, which is 3. So there goes your center. Next thing we're going to find is the direction of central box. Direction of central box. Alright? So we know that the x-axis goes side to side, horizontally, and the y-axis goes up and down vertically. Okay? So we're going to do the square root, take the square root of 4, which is the number under the x, which is 2. So central box is going to go 2 units side to side in the direction of the x-axis. And then we're going to do the square root of 16, which is 4, and that's going to be up and down because that's the direction of the axis that the number is under. Okay? Now, since this x is positive here, this would be our transverse or real axis. Okay, because it's positive. And when you root a positive number, you get a real number. Okay. On this side here, the y is negative, so this would be our conjugate or imaginary axis. Okay. The reason why it's imaginary, think about rooting a negative number. We take the square root of a negative number, we have imaginary. Okay, so that's why the variable with the number with the minus in front indicates the imaginary axis. Okay, so there we have our central box. Now, next thing we need is the C of the foci. So in this case, C is going to be the square root of 16 plus 4. Okay? Remember, we just do the opposite of whatever the sign is in the standard form of the conic between the two squares. So 16 plus 4 is 20, so we have the square root of 20. Now, in order to be able to graph this, we need an approximate value. So let's bring out our calculators and see what the approximate value of root 20 is going to be. I'm going to have you all express your decimals in two decimal places, to the hundredths place. Okay? So the square root of 20 is 4.47. So that's what C is. C is approximately 4.47. So now what direction does C go? It goes in the direction of what's real, the real axis. Okay, so it's going to go side to side. Okay, because that's the direction of real axis. Everything is happening on the real or transverse axis. Now, what is the opening of the hyperbola? Well, it opens in the direction of the real axis because this is imaginary. The y direction is imaginary, so nothing is happening there. So the opening is going to be side to side. So our hyperbola is going to look like this, one to the left, one to the right. We're following because of the direction of real axis. Okay, so if we want to know the direction of our C for the foci and opening, we just follow the real axis. Remember, everything is happening mainly on the real axis. Okay. All right. Now we have all the information we need to generate our graph. Now I want to graph my coordinate system in such a way that it fits in the allocated space. So let's see where our center is. We're going to be moving 2 units to the left. All right, that's either quadrant 2 or 3, and 3 units up. So that's going to take us to quadrant 2. So we're going to make quadrant 2 sufficiently large to compensate for the size, okay? So I'm going to put, since I want to make quadrant 2 large, I'm going to put my x-axis really low and shift my y-axis way to the right. All right, so there we have it. Okay, now let's go ahead and grab the first piece of information. But before we do that, let's label our axis. This is the y-axis, and this is our x-axis. So what we're going to do now is we're going to find the center. Okay, where's the center? Is negative 2, 3. So we're going to go 1, 2, and go up 1, 2, 3. So there goes the center of our hyperbola. Okay. Now, what we're going to graph next is the direction of the central box. So we're going to go 2 units to the left and 2 units to the right. So we'll go 2 units to the left, and then 2 units to the right, 1, 2. And then we're going to go 4 units up and down. So following the direction of the conjugate axis, 1, 2, 3, 4, up, and then 1, 2, 3, 4 units down. Okay, so these points are the midpoints of the central box. Okay, so we're going to create a central box. We're going to use a dotted line to create this. Okay, so let's go ahead and do it. We're going to use a dotted line. So let me change this. So let's draw our central box. So using a dotted line, we just connect the lines like this. Going through there, and going through there. And this one overlaps the y-axis, so that other one goes right there. Okay? So there you have the central box. All right? Now, what we're going to do next is basically graph the asymptotes. Okay, that's going to guide the graphing of our hyperbola. So to graph the asymptotes, all we just do is connect the diagonals of our central box. Okay, so through this, make a straight dotted line. Remember, all these lines are dotted because it's not the graph. They're just a setup to help us draw the graph accurately. So connect your diagonals through the center like that. There goes the first asymptote. And then the second asymptote is as follows. Draw it through the center, through the two diagonals like that. There goes your second asymptote. Like that. Okay? Alright. Now, now that we have our asymptote, we're going to go ahead and draw our hyperbola. Okay? Our hyperbola is going to fall into these two areas. The vertex is going to be at the midpoint of these two segments. The hyperbola is going to get real close to the line without touching it. Okay? So the first piece will go something like that, really close, without touching it. This one comes down really close without touching it. Because it's an asymptote, it's an arrow there. Let's draw that one again. So you starting from the vertex, you go down real close without touching it. And then for this one, you come down real close. Okay. Curves a little bit without touching it. And then the other hyperbola piece goes up real close to the asymptote without touching it, and then it curves. Something like that. Okay, so this is the graph of our hyperbola. Now what we're going to graph next is the transverse axis. The axis that goes in the direction of x is a transverse axis. So this axis right here, that is a transverse axis. And the other axis is known as our conjugate axis. Okay, so that right there is your conjugate axis. All right, so now we're going to start labeling. So what we want to label first is the center. Okay, so this is the center. So draw that out. There's a center. And the coordinates of the center is -2, -2, 3. All right. Okay, now let's grab the foci. I'm going to go 4.47 units left and right. So let's go ahead and do that. So starting from here, I'm going to go from a center, I'm going to go 1, 2, 3, 4, and a little bit. That would be that right there is F1. Okay, that's F1. Now, what are the coordinates of F1? Well, let's look at it. We went, starting from here, let's trace it down to the x-axis. So we start from our y-axis. We're going to go -1, -2, -3, -4, -5, -6.47. So it's going to be -6.47 on the x. And then on the y, we just go up 1, 2, 3. So comma 3. So there goes F1. F2, we're going to go 4.47 units in the other direction. So we'll go 1, 2, 3, 4.47 will be somewhere in the center here. And that will be F2. And the coordinates, let's trace it to the x-axis. Starting from here, we go 1, 2, 2.47, 2.47. And for the y-axis, you just go up 1, 2, 3, comma 3. And that's your coordinates of F1. Okay? 2.47, comma 3. All right, now let's go ahead and indicate the vertices and our and their coordinates. So I'm gonna use a blue line for this one. This point right here is my first vertex. Okay, so I'm gonna draw a line out. I'm gonna call this vertex 1. Okay, the coordinates for vertex 1 is easy. We can just trace it down to the x. For the x, we have 1, 2 to the left, so it's -2, comma. I'm sorry, I messed up on that one. We're supposed to start from, trace it down. When we trace it down, it's going to be 1, 2, 3, 4. So it's -4. And the y coordinate is, going on the y-axis, 1, 2, 3. -4 and 3. All right? Okay, and then the second vertex, V2, is this point right here, where the hyperbola touches the central box. So down here, we're going to call this vertex 2. And then the coordinates, we see that it's right on the y-axis, so 0 for x. And then for the y-axis, we just go up 1, 2, 3, 0, 3, and that's the coordinates of V2. Okay? All right. Now moving along, let's go ahead and write down the equation of our asymptotes. All right? We have two asymptotes. We have asymptote number 1 and asymptote number 2. Okay? Let's start with asymptote number 1. So this one right here is asymptote 1. Okay? And then this other one right here is asymptote 2. Alright? Now to write the equation of these asymptotes, we're going to simply use the formula y minus y1 equals mx minus x1. Okay? Note, the center tells you what x1 and y1 are. So this is x1, y1. Alright? So what is the slope of this line? Well, starting from the center, we go down 1, 2, 3, 4, -4, and over 1, 2. So the slope of this line right here is -4/2. That's the slope of this line going down. Well, actually, it's the reverse. we need to rise, starting from here, for this line we need to rise 1, 2, 3, 4, and over 1, 2. So it's 4 over 2. The slope is 4 over 2. If you think about it, the line is going up, right? So the slope is positive. And then the slope of this second line is just simply going to be the opposite. Is going to be the it's simply going to be the opposite of this. That's always the case because this symbol is going in the other direction. It's a reflection. So the slope of this second line will be negative 4 over 2. Okay? So this reduces to 2, and then this other one reduces to negative 2. Alright? So that's the slope. Now we're going to write down the equation using the points and the slope. So we'll have y minus y1 is 3 equals the slope, which is 2 times x minus x1, which is negative 2. As for asymptote number 1, we'll simplify. We'll have y minus 3 equals 2 times x plus 2. Now for asymptote 2, write the same equation. Y minus y1 equals mx minus x1. So we're going to have y minus y1 is 3 equals m, which is negative 2 in this case, times x minus x1, which is negative 2. Alright? So let's simplify that. We're going to have y minus 3 equals negative 2 times x plus 2. Okay, we see that they're similar. The only difference is that one slope is the opposite of the other. Alright? Alright, so there you have it. Now, the last two things we're just going to mention or label are conjugate and transverse axis. Okay, so this axis right here is known as your transverse axis. Transverse axis. And then this other axis right here, this one up here, is known as a conjugate. Conjugate axis. Okay, so that's all the information we need for this problem. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel by clicking up here. More collection of clips can be found on my TrU3L8.com. Thanks again and have a wonderful day.